I work really closely with our policy side of the house, which is led by Natasha Crampton, who's my amazing peer in all of this, but I represent how we actually put this into practice in engineering. So with that, I don't really need to say any of this after the last talk. I think everybody is seeing it. The potential of agentic AI is huge, not just in us all having assistants or things that help us, but totally changing how we build software. And the reason I bring this up is this is an enormous change function on how we work, on society, and there's a lot we have to do to get to a place where the world is ready to adopt this. Now, there's this great report that was put out by the University of Melbourne and KPMG, and they were either very lucky or very smart because they started doing this pre-ChatGPT, so they amazingly have data about how people are feeling about AI. And unfortunately, what we're finding is all of the metrics are going in the wrong direction. They trust it less, they're more worried about it, they're less willing to rely on it, which feels, and this is across about 50,000 people across 47 countries, so this is a pretty wide sample of people, and that's very much at odds with the presentation Justin just gave us. We're saying we're going to bet whole hog on this thing, right? And so this is a problem. We have to figure out how to close this gap so that we can really get the benefit of the technology, because people aren't going to want to use it. They're not going to want to use systems built on it. There's a serious risk of a backlash here if we don't figure out how to get this right. So what are the AI risks? There's a million different taxonomies. All of them are valid in different ways. But I like to think of it, and there's probably a black on black label of this coming from the International Safety Report last year. But anyway, this I think is kind of a good way to think about it. There's malfunctions, okay? Your AI agent gets confused and goes off task. Then there can be misuses of AI, and either that could be like prompt injection attacks and taking it over, or using it for things that we see as illegal or problematic. And then there's the question of systemic risk, which are the change function I was just talking about. What if all of these agents put all of the software engineers out of work? What do we do with that as a society, right? And so all of these are important to think about when we think about what to do about managing AI risk and preparing the world for this technology. Microsoft has investments across all of these in collaboration with many, many others. No single company can do this alone. But for the rest of the talk, I'm going to just focus on the malfunctions and the misuses, because this is something as technology builders we can actually do something about and put the situation in a better posture. I'm going to talk a little bit about Microsoft's approach and kind of show you some tech here. Again, all the taxonomies, all the frameworks have different things to like about them. The way Microsoft does it is really similar to the NIST framework, and so I'm going to kind of walk through the pieces and give you some real examples of how we govern, how we map risk. As Justin was just saying, measurement is huge because everything is about how you actually validate and test, and a large amount of our investment also has to be in managing this risk, both using traditional techniques and inventing new ones to really put all of this together. So we're going to do, in this amount of time, a kind of whirlwind tour of different pieces of what we do here. So starting with govern. I'm not the policy person, but I do get to spend some time here. So Microsoft's approach starts with AI principles. The thing I think that's interesting to point out here is just that they're quite broad. If you try to silo your different risk functions and you look at privacy and security and digital safety separately, you're going to have a problem because AI risks cut across all of those. You could have a prompt injection attack come in, and it could cause a security issue. It could also cause a safety issue if you're producing harmful content. It could cause other types of things. And so I think something that we have done that has turned out well in our program for many, many years now is not try to separate this and say there's already a function for that, but use responsible AI as the big tent and then activate all those other functions, help security understand the new AI risk, collaborate with privacy to understand what's at stake. The other thing I'll say, so we take those principles, no one knows how to put principles into practice, at least not your average engineer. Maybe the brilliant agents do. But the next step is then we have to turn them into a standard and like actual requirements, or teams don't know what to do. But again, if you look at the requirements, that's policy language. That's not really what engineers speak. And so the way we make this work is a lot of investment in tools, testing infrastructure, and then of course training people to understand their accountabilities. This investment is increasing massively when we go to this agentic world where the systems are building themselves, and so you need the tooling to actually be enforcing this, because you really want the humans much more in the outer loop in that kind of auditing and monitoring function. So lots of investment in that. Let's see what else I have here. Also interesting, I think everybody knows, for a long, long time we've been doing this at Microsoft. We've been totally self-governed. We had to sit down and say, like, what are these systems supposed to do? What does the world expect of us? That's totally changed now. We have sort of a huge number of regulations and actions appearing around the world. And so it's definitely a change to start thinking about what to do when there's very clearly written outside expectations. The good news about this, I'll say, though, is that yes, each one of them has their own kind of little special snowflake thing. It is forcing us to be more mature on, being able to audit and explain what we're doing to the outside world. But that said, everybody's finding the same big pieces. Hey, you should have a governance process. You should actually test your systems. You should have, mitigations in place. And so I think that's really encouraging that kind of all across the industry, because, a lot of these organizations work with different academics, with different companies, all of that, everyone's finding close to the same answer, which I think is good. That gives us a path forward. But still painful to consume all of these and then figure out how to put them into practice. Lots of effort. The other thing that's been really interesting in our practice at Microsoft is something that customers ask me all the time is like, well, what does Microsoft do versus what do I have to do? And the answer is it varies depending on kind of what level you're adopting. And so what we found is in our responsible AI practice, if we're the person building the model, that's different than if we're just hosting it as an API. And that's different than if we're taking the model and integrating it into one of our own co-pilots and creating a complete application. And even our co-pilots themselves are very much a platform where other people are building applications. And so there's themes like when we're building a model, we need to test. When we're building an application, we need to test, but we need to test for different things. So for example, if we're building a model, we're going to test for dangerous capabilities, emergent things like acceleration of biological weapons. If our customer is building on top of our model, then they need to test whether or not it makes sense for financial services, but they don't need to retest the bioweapons thing, right? And so figuring out these layers of responsibility is something that's really important to actually make this work in practice. And I think there's low understanding today of kind of where those layers go, and that's something that we need a lot more people to kind of skill up on. All right, we're gonna jump out of governance into mapping risk. So this is a slide from our AI red team. Ooh, I think we lost some text too, sorry. There's some beautiful text here that says complexity and maturity. We're pretty mature at testing traditional security. We're really not great at testing psychosocial harms there. But we have a new one of these, I feel like, every year. Every year we're adding some new category of risk that we think is important to test. And so we're spending a lot of our time over here now in dangerous capabilities and these psychosocial harms. Previously, we were spending a lot of time on security and content safety. We still spend time on these. It's not like we've solved it. We just keep adding more to the bucket. But the way we test a lot of things when we get a net new category of risk is we built an AI red team. And the AI red team publishes a lot, so you can kind of check them out. Ram, who leads it's here at RSA. But anyway, this is a unique set of experts that we've pulled together that look at how they break models and systems, but in this much wider range of risks. So not just traditional security things, but all of this whole category. And so when we get a sufficiently new technology, like as Justin said, there's these step functions all of a sudden where you're like, whoa, this one's different. And unfortunately, or fortunately, we get one of these, whoa, this one's different every month or quarter. And so we bring in red team and other experts to really understand and kind of map the risk. If you want to know about what they're finding, they've published a great paper that you can learn more about some of the specific lessons we've learned from generative AI, so check that out. The other thing is like red team. I couldn't live without them. My job would be very, very hard if we didn't have them. But they are a scarce resource. We cannot use them on every single system of our own. Our customers usually can't afford to have the same level of red team, or maybe they can afford it, but good luck trying to put one together. There are only so many experts right now. And so one of the things the red team built for themselves is Pirate, which is an open source tool that uses AI to augment red teamers so they can be much more effective in their attacks. Now, that still implies you have a red teamer and you have a human in the loop. But a lot of systems we want to test that are lower risk, we don't necessarily want to put a human red teamer on that. And so we've taken all of their great techniques and we've built them into a red teaming agent that is part of Foundry, which is our AI platform, but you can use it on any system. Kind of all the pieces are modular. And so then we're regularly updating our agent, which we can use on different systems from the knowledge of the red team and what they're actually learning. So the other lesson that we've learned that's really important is that trust and building trustworthy AI is a team sport, and this slide was made for a very specific reason. So you might end up saying there's a bunch of personas missing here, and that's true. But when we think about the active systems that we're building, you absolutely need to think about IT. They have an important risk management function today, security, obviously. But one of the things we're seeing in our practice at Microsoft is that the developer matters a ton too. If we don't build these systems the right way, if we don't have the developers investing in the right testing and guardrails, it's really hard to actually get the outcome you want. And you can think of it this way of, okay, IT can figure out that an agent is off track and stop it. But if you actually want to fix it so you can use that agent, you need to bring the developer in most of the time, right? And so the developer is a really important function. And so the rest of the stuff I'm going to show you are developer-facing tools, and we use these at Microsoft in the systems we're building. They're also things that people can use themselves externally. There are connected security and IT tools that are a huge part of this story, and they are also being presented at RSA, or we can talk about them after, but I'm just showing you one slice focused on the developer, but you need all of these pieces to kind of fit together. A big decision that Microsoft made early on that has been critical is that we build all of our internal systems on the same platform that we offer externally, which is now named Microsoft Foundry. We love rebranding. But this has been really important because the world is changing so quickly, and it gives us a single place where my team, we see a new type of attack come in, we can fix the system in one place. That helps us kind of fix it in all of the Microsoft AI systems. It also allows us to learn very quickly from a diverse set of applications, as well as from our customers. And so this took sort of company leadership to say, we want to have one AI platform. If we really diversify, then we have to go be fixing things everywhere. It's hard to keep it on the cutting edge. So we made a centralization decision that's been very critical in making this actually work for us, given what a heavy tools investment we found we actually need to make responsible AI work. Okay, so let's look at some actual stuff. Measurement, huge, so important. I think everybody in software engineering would probably agree that testing matters. That said, when we looked at AI 4 or 5 years ago, the amount of testing that people were actually doing when they shipped this first wave of generative AI was light. Now, the most successful teams invest heavily in that testing or validation function to actually make this work, but we're still seeing kind of low maturity across most organizations in this. So the other thing is what you have to test for is different. You really need to test for both kind of high-level things and low-level debugging metrics. And so this is my very basic agent example. Okay, I just want to ask the agent for the weather. It's pretty basic. Where can this go wrong? Well, it might not understand what I want, so you might have an error in intent resolution. It might pick the wrong tool for the job, right? And so you might have an issue in tool call accuracy. And these can all have downstream implications with these errors. It might actually get the right information, know what I want, but then fail to put it all together and respond to me and fail to complete the task. And so we need to build systems that allow people to both understand, like, was this agent successful in this job overall, but also what went wrong along the way, because this is how we actually both detect if there are issues and help the systems get better over time. So I'm going to jump over. I'm going to put this here. Hopefully you all can still hear me. Yes, no? Okay, I need to see Zoom. Okay, I'm going to show you what this system looks like for us here. So this is Foundry. As I said, these, we'll try talking here. These are, I'm showing you the third-party interfaces where you can use these directly. These are the same tools we use internally, and they're also something that you can use modularly through code. You don't have to use them through the UX, but it's obviously easiest to see in the UX. So the first thing here is I have an agent. This is Java. It's a retail thing. Microsoft loves to use it as an example. And I want to actually test that this system is doing what I want it to do. So I can create a new evaluation here. I can say I want to create an agent. I'm going to generate synthetic data. I could give it more interesting stuff. But then you see we've got already, for our engineering teams, a whole built-in set of different things that we want to test for. So tool selection, output utilization, the different quality metrics, is the response actually relevant, coherent, all of these should make sense from the chatbot era. And then of course different safety things. Is it producing vulnerable code? Is it vulnerable to prompt injection attacks? All of that. And so we enable you, I'm not gonna probably run this, to actually then test your system for all of these different ones. I'm going to go back here, and then you're going to get a result that looks like this coming out of your system. This is one that Ying on my team ran previously that allows you to see, like, this agent, it's really good at picking the right tool. It's got coherent responses, all of the other stuff, green, green, green. It actually is looking great on safety, but it sucks at tool input accuracy. So this allows you, and you can actually then here, let's see if I click on it, I believe, you can actually, maybe not today, go in and see the specific answers, and AI will help you figure out which examples are going wrong and all of that. Now the other thing here though is those are kind of using the system as intended test mostly. I also want to make sure I'm testing adversarially. And that's where you can create these red teaming runs, and you can decide, like, how much money you want to spend actually red teaming this, and more interestingly, what are all the different types of, we don't have tool information here. You can see all different types of attacks that you want. There's risk category, so here we go. All different attack strategies that we've put in that you can test the system. And so these kind of testing tools are something that's really important in our practice. We would have a very hard time deciding that any AI system at Microsoft is ready to ship without kind of robust testing. Now, here's a newer capability that's gone even further, because I think, like as Justin was talking about, the amount that you really want to test these systems is you need it to be a very meaningful level about what you actually care about. And so this is a new capability we've developed that actually allows you to specify what you want to test for. So here, for example, I can say I am worried about anthropomorphic design, and I can use our system here either to do kind of a quick thing, or it can go and do deep research and really understand the concept. It uses a new technique from Hannah Wallach, my friend in Microsoft Research, to actually systematize this risk, to break it down into different subcomponents and then generate high quality tests against it. And I'll show you what these actually look like. I've already generated some here. But if you look at it, it breaks it into, in this case, 31 policy components. So for example, it should comply with being conventionally polite, but it should refuse to actually express that it has a lived experience. And so this is a place where we as experts have put a lot into this tool and making it work so that our engineering teams who are not experts in these different types of risk can build on top of this tool rather than having to start from scratch, because they would not be able to break this particular risk into these 31 claims. And then, of course, this works as you expected, where there's seeds that then how do you test for this particular claim? And then, of course, results that there's only one kind of result here where you can see what was actually done, and this one only complied 2 out of 3 and make your system better. So this is one really important part of the system testing. I'm going to go back and show you what do we do about mitigation. I think Justin covered this really well, but part of the game here is we used to use humans really tightly in the loop. Okay, they're reviewing every response from the AI system. That's the chat era. Observability is what enables us then to actually move that human to the outer loop. And so these tests, we also enable them to run online continuously in our systems so that we're not only, because these systems are so dynamic, testing pre-deployment, but continuously making sure it's still adhering to the properties we say we care about. Now, great. Okay, we've tested it. We found some issues. We actually want to do something about that. And so managing is where we're having to equally invent a lot of new technologies. So I'm going to cover this really high level. Okay, agents can go wrong in a lot of ways. This same survey that I like, you can kind of see 3 big categories people are worried about right now. Agent doesn't do what you want. Agent is vulnerable to new types of attacks. And leaking sensitive data. And what do we do about these risks? Well, we're finding that we need to mix old and new technologies. So agents are a new type of entity in our systems, right? They kind of work like users sometimes. They kind of work like apps sometimes. Well, we have ways to secure users and apps and devices. And so extending that existing data governance, identity plane, everything to work for agents is part of this. And so we have an agent ID and Entra, for example, now. But then also, there's new types of risks that are more specific to these autonomous agents that we are developing technology for, and we put these 2 pieces together to actually make this work. And I'll give you an example of the new a little bit. So you could make a really easy data security policy and just say, okay, internal agents are only internal, external agents are only external. But it's not that interesting, because to get a lot of value from an agent, what do I really want to do? I want to take all my brilliant internal sensitive data. I want the agent to think about that. I also want it to understand the external world knowledge and then be able to put those 2 things together. And so you have to be more clever about what to do, because there's this thing that many people call the lethal trifecta, which is you can have untrusted content come in, therefore you can get attacks to come in. If it's accessing your sensitive data and it has external tool calls, you can get unpredictable model behavior that leaks sensitive data externally. So what do we do about this? We add a variety, still want to do things like least privilege, access and all of that, but say it actually needs to access this data. So we layer different things on top. We have different preventions and detectors for prompt injection attacks coming in. We have things that are analyzing the data going out. And we have new capabilities that are looking at, is this agent actually doing what it's supposed to, or should I stop it? So we bring these different detectors in at different intervention points to really make this work. And I have to wrap up, so I'm going to just say 1 or 2 more things here, which is, so we found that you need 4 things when we really think about agents. Observability. Observability is really important everywhere to actually know what's going on and detect these issues. We've been partnering and contributing to the OTEL standard to help sort of make a standard for all agents there. Controls, old and new, I just mentioned a little bit there. Deep integration with traditional security things. So if your agent is under attack, I want the controls to stop the attack, but I also want my security operations team to investigate that. And so this is a place where we're connecting our developer plane deeply with the security operations so that they can participate in this. The other thing is, you don't know where to look. We don't want just one agent. In Microsoft, I think we said we have 500,000 or something that security is managing now. And you need to know where to look. And so being very smart about how to help people understand where there is risk, where the system is going off task, is really important here. We have a developer capability here called Foundry Control Plane that brings all of these capabilities together for the developer in a nice interface, which I don't have time to show you. And so it's really about bringing the testing I showed you, controls, all of this together so that all of these tools are available to the developer in collaboration with security and IT to really make this work. If you want to use Foundry Control Plane, it's here. There's lots of nice links. The other thing I'll say is you want to learn more, like so much of our external tools at Microsoft are built on how we have actually learning to do this with every AI release we see at Microsoft and what we're finding our company actually needs to do this at scale. We publish a transparency report every year on how we do responsible AI, so you can check this one out. This is from last year, and we have a new one sort of coming out soonish. So that's where you can learn more about our whole kind of program overall. And then I'll just wrap by saying, like, I think this technology is so exciting, there's so much potential, but if we don't get that foundation of trust in place, and that's gonna take all of us, we're really gonna limit what this technology can do to help people and the impact that it can have. So appreciate you all listening and happy to chat more after.
I think we can do a few questions while we
Sure.
set up for the panel, and if maybe Thomas, you can help set up for the panel, or folks on the Grafster side could set up while we do it. Yeah, I don't know if anyone has a question for Sarah already that you've been thinking about.
I'll take pointy comments too.
Justin?
Is it okay if I ask about that? Just regarding trust and sentiment, my impression is that it's actually bimodal. So that one showed one distribution. Can you say a little bit about the developed world, separate from the maybe less developed world and the sentiment?
Yeah, at least in the data in that report, the bimodal is right. Actually, what that report found is that there was more adoption in the less developed world because there wasn't pre-existing systems that they already trusted. And the more you adopted, the more you trusted it. So I think like getting people comfortable to get hands-on with the technology does remove some amount of the fear, because you're no longer like, this is an abstract thing I don't understand. You're like, oh my God, it's really amazing. Also, it's really dumb over here. Okay, and you get more comfortable with it. So I think a really important thing is to make sure that people have access to this technology so that they can participate both in governance and remove the fear.
Let me give you the mic here.
Yeah, just a quick question on one of the initial graphs, or one of the initial slides you talked about the concept of fairness as part of AI governance. Given kind of the evolving conversation, how do you navigate standards of fairness, especially globally and across different cultures?
Yeah, it's obviously a very topical question. And, I think the answer I would say in terms of how we're thinking about it is it's still really important to understand how your system behaves, so we still need to invest in the testing and the tools to understand and control your system behavior. And then ultimately, it's up to the specific application to decide what makes sense in that deployment context, whether that's their legal environment, their customer environment, all of that. And so we've focused a lot of our energy on creating those foundational capabilities, but making sure that the actual final decision is in that local context and control. But it's something that we've seen a change in how people feel about harmful content coming from these systems as well. And so that's one of the interesting things about this, is that we are very actively as a society navigating what we think is appropriate AI behavior, and it's not going to come out uniform, of course. And so that's why making sure we have the controls so that you can adjust rather than like baking in one answer overall is going to be really important. Cool.
Great. So thank you, Sarah.